I'm Major Micah Bushouse. I'm a PhD student in computer science at NC State University down in Raleigh. And I'm also an active duty cyber officer attending the Army's Advanced Civil Schooling program. My collaborators are listed here. And what we're going to talk about today is the mechanization of cyber defense. In a nutshell, what we're trying to do is we're trying to make our teams more effective. We're trying to raise their level of play up from where we are today by taking them out of the tasks of manually shepherding and executing their tools. So can we raise them above that, automate some of this stuff, and raise our game in the process. So that's what we're going to talk about today in a nutshell. The Army Cyber Branch and all teams in the cybersecurity field their primary platform is going to be the computer. We need to optimize this platform, the human interface aspect of this platform. And we're going to look at that today as well. Mechanization. So without getting too precise, mechanization, you equip an infantry force with wheeled, tracked armored vehicles. One of the reasons you do this is so they can keep up with armor, that is, tanks. That's a good thing, and so the analogy here is we're trying to do the same thing for cyber. Do I have a clicker? Yes. So here's our problem statement. We're going to focus on two sub-problems that we've identified. Manual tool transitions, so that is the act of a human having to bridge the gap, the difference between the execution of two tools. And also poor user interfaces. So our user interfaces are exacting a tax on our operators. They're distracting our operators. They're costing more time. We need to look at that as well. We're going to take a quick break, talk about what tools are anyway, and then we're going to get into some potential solutions in the short term that we can use to address this problem in a short amount of time. So here's the backdrop. Everybody knows the DoD's cyber growth. Anytime you grow quickly, and this is quick for the federal government and the DoD, you're going to run into problems resulting from how do you train these people, how do you retain these people, how do you build a culture, how do you organize them, and how do you equip them? So let's talk about equipping for a minute. Equipping is harder here because of the thousands of potentially useful cybersecurity tools out there. Tools that were written across the globe. Tools that were written 15 years ago that we still use the code bases for. Tools that were written across language, human language, computer language, technology stack. And then finally, tools that are differing in quality and scope. So imagine we have an acquisition spreadsheet that has all the tools that we're gonna equip our forces with. On any two rows, you might have a line that has a tool that's 50 lines of code that's just phenomenal. It was written in someone's basement. And then right next to it, you might have a tool that was written by a defense contractor, multi-million lines of code tool. How do we organize ourselves around differences in variety like that? First, let's take a break and talk about problem number one. So problem number one is that manual tool transition problem I talked about. And we're going to do it by talking about holiday shopping. That's how we're going to bridge this. So imagine it's like early December, like dangerously early December. The cutoffs for Amazon shipping are rapidly approaching. You're adequately caffeinated. You're adequately feeling guilty about yourself. It's time to get to work. You open up Outlook. You open up an email that contains a wish list from your loved ones. You select an item out of that email. You copy it, Control-C to copy. And you open up a web browser and paste that into YouTube and do a search. And you watch a review for that gadget. You think it might be a good gift, so you back up, and this time you remember the name of the tool, you open up a second tab, and you do a Google search for the gadget and append the word review at the back. You read a review about the gadget, and you decide it's time to buy. This time, at the bottom of that review, listed for you is a link to Amazon. You click the link, you go to Amazon, you buy the gadget, you move on with your day. So this is that workflow notated as a graph. So you start with Outlook, you flow through the graph, you back up, you go back down, and you end at Amazon. I guess I should have been doing this the whole time. There we go. The arrows annotate whether that task was manual or automatic. So in the manual case, remember you had to control copy, you had to remember the name of the tool, add information, in order to get it into a format that the next tool expects. The black stuff kind of happened automatically. Yeah, you had to click, but just trust me, it was more automatic than it could have been. Turns out cybersecurity is a little bit like holiday shopping. At least you can model the two the same way. In this instance, what we'll do is this graph shows running two tools, combining their outputs, and inputting that into a third tool. Now, if you look at this in terms of time, what you'll see is the computational aspect of this doesn't take that long. Maybe 3 or 4 seconds on the front end, 3 or 4 seconds on the back end, but then you have this person in the middle. Might take a minute to combine the output of the first two tools and feed it into the third. Might take 2 minutes. They might get distracted. They might start but never finish. They might get interrupted. This is a problem. This is a distraction, and it's costing us time. Let's talk about problem number 2. Problem number 2 is poor user interfaces. So we've all used a web browser before. We've all perhaps encountered a problem like this before where you have 20 tabs open simultaneously. This happens when you're doing cyber too. The teams will be very busy doing something. A lot of our tools are web GUI based, so you're using this web browser a lot. And they're multitasking. They're following investigations. They're testing theories. They're getting interrupted. They're switching over to a different investigation. They're coming back to the first one. Their priorities are changing. And as a result, this linear tab bar gets pretty jumbled up. The investigations get interleaved. And as a result, we're stuck using the most efficient algorithm available to us at that point if we want to backtrack and go back to where we used to be. Manual linear search backwards through the tabs until you find that last known point for that particular investigation. It's not a pretty picture. One thing we could do is visualize these tabs as a hierarchy. So the child-parent relationships between the tabs would naturally kind of filter out each investigation naturally. That's one potential thing we could do. But this is what we're stuck with today. You can play the video, please. So this is what we don't want. So this is the game called StarCraft, and it's still pretty popular in esports. That is competitive video gaming. That is a thing. And the thing about StarCraft is it has a very low-level user interface, meaning that if you're playing the game, you have to give explicit commands about units to do which things, units to attack, buildings to build. There's really no button that you can push that is the equivalent of computer, build me a glorious stronghold, you know? So as a result, these professional gamers will spend months maximizing their ability to push orders into this game, to the point where they will wear sandbags on their wrists to get better at actions per minute, action being a mouse press, a click, so on and so forth. This is the cyber equivalent of weightlifting. And if there's anybody out there from the cyber branch, don't write that down. But the connection to our cybersecurity teams is that they're facing similar problems. They're having to fight with these user interfaces, practice at these user interfaces, and that's taking time away from things that they could be doing, exercising their judgment, exercising their experience, their intuition, not doing this mechanical aspect of fighting with a UI or moving data between two tools. You can cut it, please. So those are the two problems. Let's take a quick break and talk about what a tool is. So basically, for the purposes of this talk, a tool is a unitary software component. It has defined inputs and outputs. These, again, are red or black, depending on if they're automatic or manual. So if this was Outlook, red would be you typing in an email. Black would be Outlook checking the mail server for new mail. And one other thing is that these are generally, you can execute them independently. So a tool is relatively independent of other tools. So in cybersecurity, a lot of tools do very specific things. So what you'll do is you'll chain together tools in this kind of tool graph. It's kind of like a pipeline where raw information comes in on one side and processed information comes out on the other side, actionable information, moving the ball down the field. Here's some examples of some of the more tightly coupled software ecosystems that demonstrate this idea. But what you'll notice is that there's still some red arrows in there. So what some folks have done is they'll slap an operating system underneath one of these sets of tools. They'll think up a really cool name, and that takes most of the time. And then they'll hang it online for you to download in order for you to use. The good news about this is that you can get started quickly. A lot of the legwork is already done, and maybe even some of those arrows turned red for you because of the additional QA automation that they've added. But one of the bad sides is if you're using these free platforms that are out there, there's nothing to say that that maintainer of that platform doesn't move on to something else and leave you out to dry. So the Army's DCO Maneuver Baseline program, quick aside, is aimed at targeting this sort of thing, using just enough operating system to get you off the ground and installing only the tools you need for that particular workflow. But that's something for another talk. Workflows. So you take multiple sets of these tools, you string them together, and you have a high-level task that you're trying to achieve. So this is the battle drill level task. You might have 10 of these that an incident response team practices repeatedly to get fast at. This is where you start inserting people, and this is where you start having a variety of technologies, a wide scope. So on one side, you might have network traffic being scanned. A binary might be carved out, gets thrown into a sandbox, blows up. Something falls out of that, you make a decision, a mitigation action, a block, something like that. But it's many tools working together to achieve a high level of effect. Okay, so that's what a tool is, and that's how it fits into the greater picture. I hope that helps a little bit. Enabling information flow. So now we're going to talk about some solutions. The obvious solution to automating tool transitions is just make sure the tools speak a common language, make sure they're written to talk to a common API or accessible in some way that you can automate, and you don't require this human level of interaction. A lot of tools are written to be used by humans, so they output text that a human can read, they input commands that a human would type. We might never get there. There's always going to be that miracle tool that gets written in someone's basement that they just don't program, they don't agree to a specification, any specification we might come up with. It might be a vendor that just doesn't want to follow that specification. It might be any number of reasons. It might be an old tool. So what do? Well, we have to cope somehow. The approach that we're taking in this project is to introduce the idea of software wrappers. It's a very basic idea. You just wrap the tool in a piece of software that handles translation. So you translate from a unified format into the format that tool expects, and again on the other side. A lot of words up here. We're going to skip through this, but basically that's what we're going to do. Introduce a software framework. It doesn't really scale that well because each tool you kind of have to introduce its own nuance, the wrapper layer. But that's the way we're taking initially. And as a result, let's make this concrete. So this is a 4-tool set that basically does some scanning on your network, does some network history lookup, and does an asset management query, combines that into one piece of information, and then pushes it into Visio and is diagrammed for the local IT folks. This is one of the things you first want to do when you get on the ground. You're responding to an incident. Let's get around the table, look at a network map, and let's talk about stuff. Well, this is one way to get that automatic network map using that software translation layer. It's kind of expensive because you have to do this per tool, but as we get better at it, and as we target the most used tools first, we'll get some gains. Next video, please. Okay, so now once we've done this, once we've introduced this software wrapper layer, and this tool transition idea has taken hold, and the human's no longer the sticking point between two tools, we can do pretty cool things. Like this is FlowHub, and it's flow-based programming. It's kind of a niche thing. And basically, you'll drag your tools onto this canvas, and you'll link them together using the mouse. And in this way, we have people designing these tool graphs, these sets of tools, for very mission-focused reasons. So no longer do we have to go back to the bat cave, figure out these tool sets, how we're going to use them, test them. You can do it in real time based on the problem that you're seeing on the ground. So this is some of the cool things that you can do once you've automated those tool transitions. Thank you. So let's talk a little bit about user interfaces. And something that we can all relate to is the Windows clipboard. Those of us who are easily distracted will copy something very important in there, grandma's recipe for pie. You get distracted, you go on YouTube, 45 minutes later, 3 cat videos later, you come back, you copy something else into your clipboard, and poof, grandma's pies are gone. Smart clipboards, the first thing they introduce is a history feature. So grandma's pie will just slip down to slot number 2 in your clipboard and everything's okay. In addition, from the cybersecurity aspect, they're programmable, so they can recognize the data types that you copy into there. So if you copy in a file hash, or if you copy in a web URL, the smart clipboard is smart enough to say, oh, this is a file hash. Let me fork off a subprocess and query a database somewhere, and we'll show the show up a pop-up temporarily that shows the result of that query. We're removing the human from that mini subtask completely, freeing them up to do something else. They're also synchronizing. So if you have a small team of 5 incident responders, you're huddled around a table, or you're remote, you copy something into your clipboard, it gets transmitted to everyone else's clipboard and appears in a separate tab on their clipboard. Gone are the days where the only way to do that is copying and pasting into a chat window. It's now done automatically, at least for some cases. There's some other things in here. We're going to skip through it for my sake, and we're going to talk briefly about graphical user interfaces versus command line interfaces. And if you're a geek, you know they're like this. People draw lines in the sand, and they say one is better than the other. Well, you really need to have both. If we're going to have a cyber workforce where you have entry-level folks and you have master-level folks, if you're going to use the same tool throughout, you need to be accessible to that entire workforce. So the folks that are new, or the folks that don't use a tool very often, they need to be able to have that graphical user interface that kind of walks them through the process, shows all the options they can click through. For the experts, they just want you to get out of their way. Don't put an interface in front of me. I want access to the command line. I want a script, blah, blah, blah. You really need to have both. Now, to make that idea concrete, we're going to show a quick sequence where we're going to do one cybersecurity task, and we have 2 panes. It's occurring simultaneously in each. On this pane, someone is only using the mouse. On that pane, they're only using the keyboard, using an extension to a web browser that allows you to surf the web using a keyboard. And what you'll notice is that this task occurs it finishes at the same time, meaning that the mouse and the keyboard are really no faster than each other. But the keyboard does offer some advantages, and being a command line guy, I got to talk about those real quick. You can multitask quicker. You can automate it quicker, so you don't have to worry about mouse movements. Automating mouse movements, it is troublesome. And then finally, there's an aspect to any time you're going to have a technician using a graphical user interface, he or she's going to switch their hand between the mouse and the keyboard frequently. You watch next time you're surfing the web or you're typing an email or something. You're going to be doing this a lot. As you scroll through a web page, you go back, you type, you scroll some more. This takes time and it takes energy. And if you're going to have people doing this for 12 hours a day, because it's the Army, 12 hours a day, 14 hours a day, for 6 months, it's going to add up. And these small gains make a big difference. So thank you very much. So to conclude, this is what we're going for. Faster humans and smarter machines. It should be flipped. But we need to look at this as well if we want to maximize the utility of our teams. This is a work in progress with my collaborators. If you're interested, talk to me after this for some more details about the specific tools we used, the clipboard manager, or that proof of concept workflow that we produced. And if you're interested in contributing, please see us also, because we by no means have the right answer. We're just working towards the right answer. The guy right before lunch, so I'm going to end a little early. I did manage to survive by 45 seconds.
Good job.
Thank you very much for your time. I had fun preparing for this, and I had fun talking with this problem with you. They're both important problems, and I hope you learned something. I'll take any questions now.
I was wondering if you've looked into separating the GUI from the CLI so that you can run both at the same time, rather than forcing your poor Bash friends to have to use a GUI for everything.
Yeah, I think, and there's tools that will do this. So they have this middle interface that can plug a GUI into or plug a command line into, and I think that's the right answer. Yeah, there are tools like that, but not all of them are like that. We should probably do more of that.
I think there's an underlying assumption, maybe just my perspective, that in order for this to be responsive, right, it's got to continue to evolve, and it's specifically tailored to our teams and the way that they operate, the tools they need to use. So do you I mean, do you think that this is something that we can pay someone to do and develop for us, or is this something that we need to have our own developers creating this capability?
That's a good point. And ultimately, we're not trying to replace any product that might occur in the future. We're just trying to address the short-term problems that we see. So we're not trying to compete with anything. This is designed to be kind of generic. I think this is a problem that you'll see in cybersecurity. In particular, that's what we've been looking at, but it occurs just about anywhere where you have people using a computer to do some technical things. Does that?
You're putting a software wrapper around the tool to automate the process. And the tools in themselves are sufficient. So you've already proved your hypothesis that this is value added. So what's next?
So what's next? I think, like I said, our goal was pretty scoped to be valuable in the short term. So I'm not really sure what's next. I think we're going to continue going on this road, playing with things, see what does work, see what doesn't work. Do people like this idea? Will people pick this up? Or will they say, oh, it's just another thing I don't want to use? So I don't really have an end state in mind, but I'm just trying to provide value in the short term. Is that?
A lot of the technologies there to do this today. I think a bigger challenge is getting operational commanders to have confidence and trust in the system so that these automated processes won't break command and control.
Right.
How do we address that aspect of the problem?
So the question is how do we make sure that these tools don't, with or without automation, how do we make sure the tools don't break things? That's a good question. I think where we are today is we will break things. I think as we mature, as this force matures, as its culture matures, there are going to be some heartbreaks where we do, something is done that brings down a network that impacts an operational mission for the sake of security. And so I'm going to have to punt on that one too, but I will say that it's something that is a problem. Yeah.
I was wondering how much overhead you're incurring with the use of the software wrapper around the programs.
Good question. So it's very low. Basically, it's basically just doing translation. So there's a few other things that it's doing as well. You can have it run on a loop. So this wrapper will run that tool on a loop, so that the technician does not have to do that. But it's very minor. You're basically moving data fields around, the things that the human would do anyway. So by virtue of a human doing it, it's probably not that computationally expensive. So it's very low.
About 11 years ago, I was in the government, funded a research program very similar to this. It was focused on counterterrorism. Same problem, user interface, wrappers. I have a lot of lessons learned. We spent a lot of money, 6 years. Willing to share it with you.
Sure. That'd be great. Thank you.